Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 5F assignment. First one we're going to take a look at here is number 2. Suppose a sequence has S of 4 equals 13 and S of 5 equals 20. So S, remember, means the sum of the first 4 terms equals 13. So we have 1, 2, 3, 4. Add those all up, and it's going to equal 13. Okay, that's a 3. That's a terrible 3. There we go. And then now it says the sum of the first 5 numbers is going to equal 20. So 1, 2, 3, 4, 5 is going to equal 20, right? So they're asking, find the value then of u sub 5. So if you take all these, those are going to be the same, those are going to be the same, those are going to be the same, and those are going to be the same. 13 plus what gives us 20? 7. So u sub 5 has to equal 7. Okay. Next one, take a look at number 4. For each of the following sequences, write down an expression for S of n, and then find S of 5. So our expression for S of n, this is where they're going to want to actually have you use this summation notation, right? So what we want to do is S of n is going to equal, and then we got our summation notation, that big funky Greek E, right? Looks kind of like that. And we're going to start with k equals 1. Pretty much always the same. That just means going from one term up to, and since this doesn't have an end, we're just going to go up to n amount of terms. And then in here, we're going to simply enter in our u sub n formula. Okay? So if you'll notice here, we're adding 8 here, 8 more there, plus 8 there. So our difference is 8. Our first term is 3, so we can just plug that into this formula here, and that's what we're going to write here. Okay, so it's just this notation business. So we've got u sub n is going to equal, our first term is 3 plus n minus 1 all times 8. So u sub n equals 3 plus, distribute that 8 to both parts, we get 8n minus 8. So we get u sub n equals 8n minus 5. So we get 8n minus 5, and that's what we're looking for part 1. Okay, so again, this means the sum of the first n terms will equal, and this means we start with plugging in number 1 first, and then 2, and then 3, and then 4, all the way up to n. Sometimes that's an actual number, sometimes it's not. This is like a general formula, okay? And then this is what you're plugging in. So if we plug in 1 here, 8 times 1 is 1, minus 5 is 3. There's our first term. If we plug in 2, 8 times 2 is 16. 16 minus 5 is 11. There's our second term, and so forth and so on. Okay, this is just how you write it down with the using our summation notation. Okay, part 2, find the S of 5. So now what we want to do is we can do a couple different things here. So for part 2, S of 5 means that we're going to now take this summation notation, and k equals 1, but instead of going up to n, we're going to go up to the first 5 terms, and then we'll do 8n minus 5. All right, so if you plug in 1, we get 3. You plug in 2, we get 11. They want to know what the first 5 numbers are going to be, and then we add them all up. 19, 27. If you plug in 5, 8 times 5 is 40, minus 5 is 35. Add these all up, and that's what the sum of the first 5 digits is. Okay, so let's see what's that. It's going to be 35, 45, 55, 65, 75, 85, 95. Okay, so the sum of the first 5 digits of this series, the sum, adding them all up, gives us 95. Now, instead of doing this, writing it all out, we actually have these formulas as well. And this is an arithmetic series because you're adding the same number each time. Okay, so this is if we know what the first term and the last term are, we can plug it into this formula here. If we don't know what the first and the last term are, we can plug it into this. We figured it out that it was 35, but let's pretend we didn't know that. Again, it would work for either one. These are both basically doing the same stuff. It's just with different information. So S of n equals, n is the number of terms. So that's going to be 5 over 2 times twice the first term, which we already knew was 3, plus n, number of terms, 5, minus 1, all times d, the difference, which we figured out earlier was 8. Okay, excuse me. And then all we're going to do now is just figure out what this all equals. So we can do 5 divided by 2, all times, we can just put this in just like it looks, 2 times 3, I'm going to do plus 4 times 8, because I know that 5 minus 1, just saving a little bit of time there. Gives us, hopefully, 95, and look, there it is. S of n equals 95 that way, too. So that's with the formula. That's with doing it by hand. If you're only doing up to, like, say, the first 5 terms, 5 terms, 6 terms, 7 terms, probably anything less than 10, depending on your formula, on your series, I mean, probably isn't too awful to do by hand, but once you get like up past 10, you're going to definitely want to use this formula. Otherwise, you're going to be adding a whole bunch of numbers together, and it just it's so much easier to use the formula. Okay? All right. Let's look at the next one. Expand and evaluate. Okay, so expand and evaluate basically just means we're going to plug our 1, 2, and 3 into this here. So 4 times 1 is 4. 2 times 4 is 8, and 3 times 4 is 12. Add those all up. That's 24. Okay. Now in this one here, this is probably, see again, probably we only did 1 through 3. This is going to be probably easier just to do this by hand without using the formula. Okay. This one here, 1 through 5 of this here. So we can do it. We can just find all 5, add them all up, and away we go, or we can plug it into the formula. So I'm going to do this. I'm going to plug it into the formula first. Okay, here's our formula. So this is arithmetic. Geometric is when you've got like some powers and stuff going on here. So this is not geometric yet. This is still arithmetic. So if we wanted to do that, we don't know what the first or the last term is. So let's use this one here. S of n equals, number of terms is 5 over 2 times twice the first term. So let's plug 1 in. 11 minus 2 gives us 9. So that's our use of 1 is 9. So 2 times 9 plus number of terms 5 minus 1, all times our difference. And our difference is negative 2. Okay, so we plug that all into the calculator. Oops. Sorry. There we go. Push on. We got 5 divided by 2, all times 2 times 9, plus 5 minus 1 is 4 times negative 2. Gives us that the sum of those first 5 numbers of this series is going to be 25. Okay, so that's with the formula. If you actually go through and do this without the formula, if you just figure out what each of the numbers are, so if we plug in 1, we got 9. 11 minus 2 times 2 is 4, so that's going to be 7. And we're actually just going down by 2 each time, 5, 3, and 1. And then we just add those up. That's 10, that's 20, and that's another 5. So S of n equals 25 that way too. Again, probably easier this way. I just wanted to show you that it works fine with the formula too. Okay, let's look at one more, and that is number 8. Expand n summation notation k equals 1, ending with n, all to the k. Then write the expansion again underneath with terms in reverse order. Add the terms vertically and hence write the expression for the sum, S of n, of the first n integers. Okay, so this is kind of one of those theory type questions. Okay, so expand, then write the expansion again. Okay, so first term 1, second term is 2, third term is 3, and we can keep going on forever and ever until we end up with the nth term, right? And then 1 less than the nth term, and this is kind of important, is this going to be n minus 1, right? So we get that. So first term is 1, second term is 2, third term is 3. The second to last term is n minus 1, and the last term is n. Okay. Now it says to go back through here and rewrite it in opposite order. Okay. So underneath here, so this is going to go underneath here, n minus 1. This is going to be n minus 2, all the way down to the second term was 2 and the first term is 1. Okay. And now it says add all these things together. Okay, so look, we've got n plus 1. And then look, n minus 1 plus 2 is n plus 1. N minus 2 plus 3, n plus 1. N minus 1 plus 2, n plus 1. N plus 1, n plus 1. So those are all a bunch of n plus 1s. So we have n plus 1s. How many of those do we have? We actually are going to have n of those. So like if this was 10, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. And it's going to be this, when you add them together, you get this n plus 1, and there's going to be n number of those. I know that's kind of a weird concept there. Okay. But the thing is, we actually have 2 of these sequences. So we only want 1 of those. So then we have to take that all and divide it by 2. Okay, so that's where we get S of n equals n times n plus 1 over 2. That is the sum of the first n integers. So like, let's say if we want to know what the sum of the first 37 numbers is. So 37, the first 37 numbers. So you'd say S of 37 equals 37 times 37 plus 1 all over 2. Okay, so we would do, clear that out. There we go. 37 times 37 plus 1 is 38 equals, and then divide that thing by 2. And then the sum of the first 37 numbers altogether is 703. Now that is definitely easier than adding 1 plus 2 plus 3 plus 4 all the way up to 37. Okay. Again, that was just kind of try to help you understand what's going on with that. Okay. All right. Oh, yeah. Let's see. Add the terms vertically. Right. Okay. We did both parts. Okay. All right. If you have any further questions on anything from 5F, please feel free to ask. Thanks.